Up today, we're going to take a look at how to determine what kinds of bonds we would have when we have different elements. We're going to do that by looking at an equation, plugging it into our calculator, and analyzing the results so we can determine what kinds of bonds there are. Let's take a look at that equation as well as some examples of how to solve it. The first thing we'll need with determining what type of bond we have is a way of determining what kind of ionic character that compound would have. When we look at two elements, we can use this equation. I know it looks scary, but we'll break it down here in a second. It's not as bad as it looks. But we can use this equation to calculate what kind of ionic character a bond between two atoms will have. In here, the only thing that can change is this part right here, this delta E-NEG. That is a change in electronegativity. So this delta, this triangle, means a difference or a change in electronegativity. So we look at the difference of electronegativity of our two elements. E is simply a number. It's an irrational number. It's Euler's constant. It's very similar to pi in that it's an irrational number that we just use as is. And we raise it to a power dependent on what that difference of electronegativity is. Once we've used this equation, there are three different kinds of bonds we can get, and it's dependent on the percent ionic character that comes out of the equation. If I plug in this equation and I get a percent ionic character greater than 50%, I say this is an ionic bond. If I get a percent ionic character less than 50%, I say it's covalent. However, we do break covalent bonds down into two types, and that is broken around the 5% margin. So if I've got less than 50 but more than 5%, so my ionic character is less than 50 but more than 5%, I say it is a polar covalent bond. And the last option is my percent ionic character is less than 5%. I say these types of bonds are non-polar covalent. Greater than 50%, I have an ionic bond. Between 5 and 50, I have a polar covalent bond. And less than 5%, I have a non-polar covalent bond. Ionic bonds are where electrons are stolen. One element rips the electron from the other. Covalent bonds are where electrons are being shared. And in each case, it's a slightly different kind of sharing. Polar means each end of the bond is slightly different. One element is going to pull harder than the other. Non-polar means both ends are about the same. They get shared pretty much equally. So complete stealing of electrons, unequal sharing, equal sharing. Let's take a look at some examples as well as how to use this equation. The first example we're going to look at is between sodium and chlorine. The first thing we will need to know about each of them is their electronegativities. We get that from the chart that is provided in your Schoology folder. The electronegativity of sodium is 0.9, and that of chlorine is 3.0. Now in the formula, the first thing we have to do is take our difference, or our delta, of our electronegativities. We typically do the largest minus the smallest in that one. So I'll take 3.0 minus 0.9. In this one, our delta E neg is 2.1. We can then plug that into our equation and work it through our calculator to calculate our percent ionic character. Let's take a look at how we would plug this into the calculator. Let's take a look at how to plug this into the calculator. Each calculator will be a little bit different, so if you're not sure or not able to come up with the correct answers from this, please stop in and see me. I will walk you through how to use your calculator specifically. But this is using Desmos, which is an online calculator source. When we type it in, it's going to look very similar to the equation we have. First thing we're going to need to do, we're going to open a parenthesis and type in 1 minus. Now that E is, again, simply a number. It's an irrational number. You can think of it kind of like pi. On most calculators, it's a second function. So you'll have to hit second first, and it's usually a second function of the LN button. In Desmos, it's its own button, so I'm going to go ahead and hit it. Some calculators will automatically open up a parenthesis when you click that, some won't. If it does not, you need to make sure to go ahead and open a second one. And then the next part of the equation is to make it negative. In Desmos, to make it negative, we just use the subtraction button. However, on most handheld calculators, there is a specific button that you will use to make it negative. Make sure you use the correct button. And then we're going to open a third and final parenthesis. And here's where I plug in my delta E neg. In this example, it is 2.1. So that is my delta E neg. And then I divide that by 2. And in Desmos, I have to hit the right arrow to get out of the fraction. And I'll close my first parenthesis. And then I find the button that squares it. So either x squared or in this case a squared. I then close another parenthesis. And I have to hit the right arrow to get out of the exponent and close my last parenthesis. And the last thing I'm going to do is multiply by 100. We don't plug the percent into the calculator. We're going to treat the percent as a unit rather than something we would plug into our calculator. And for sig figs, sig figs get weird when we start dealing with exponents. So for our purposes, if you round to the first decimal place, it'll be close enough for what we will need. So this example, we have a percent ionic character of 66.8% after we round. Once we finish plugging it in, we just record what our calculator has said at 66.8%. Looking at our chart, because my percent ionic character is greater than 50%, I know that this bond will be ionic. Let's take a look at another example. The next example we're going to look at is a bond between carbon and hydrogen. Again, we go to our table to look up what our electronegativities are. Carbon is 2.5, hydrogen is 2.1. Next up, I need to calculate my delta E neg. Again, I take the larger, in this case the 2.5 of carbon, and subtract the smaller, the 2.1 of hydrogen. In this case, I get a delta E neg of 0.4. I can then plug that into my calculator to calculate the percent ionic character. Let's go to our calculator to do that. In this example, we have a delta E neg of 0.4. So again, we open a parenthesis and type in 1 minus. I find my e to the x button, and since it doesn't open a parenthesis, I need to open one myself. Make it negative and open a third parenthesis. Again, here's where we plug in our delta E neg, which in this case is 0.4. I divide that value by 2 and close my first parenthesis. Then square that value and close another parenthesis. And again, in Desmos, I have to hit the right arrow to close my last one, and I multiply by 100 to convert it to a percent. Again, we round to our first decimal place, so the percent ionic character for this one will be 3.9%. Once that we plug it into our calculator, we see that our percent ionic character comes out to be 3.9%. We look back at our chart and we see that since this is less than 5%, it is a non-polar covalent bond. Let's take a look at one more example. The last example we're going to look at is a bond between nitrogen and fluorine. Again, we go to our chart to get our electronegativities. nitrogen is 3.0, and fluorine is 4.0. Once we have our electronegativities, I take my larger minus my smaller to get my difference in electronegativity, which gives me 1.0. Let's go to our calculator to plug that in. In this last example, our delta E neg is 1.0. So again, I start by opening a parenthesis, type in 1 minus, and I find my e to the x button, and open my parenthesis since it doesn't, add a negative, and open a third parenthesis. In this one, my delta E neg is 1.0. I divide that by 2. In Desmos, I have to hit the right arrow to get out of the fraction so I can close it. I square it, close a parenthesis, come out of the exponent to close the last parenthesis, and multiply by 100. So in this last one, our percent ionic character is 22.1%. And once we plug it in, we see that our percent ionic character is 22.1%. Looking at my table, my percent ionic character is less than 50%, which means it is some kind of covalent bond, but it is more than 5%, which means it is a polar covalent bond. Now that we've gone through some examples, we've looked at a couple of them, we can use this to springboard into how to draw Lewis structures for these elements, as well as using it as a baseline as we move into a lab. We're going to look at some physical properties of some compounds that we know are polar covalent, nonpolar covalent, as well as some ionic, and be able to identify unknowns from this. So our next step will be to look at Lewis structures, and then we're going to be diving into a lab to experiment with this. Good luck, and if you have any questions, be sure to reach out.